Hey everybody, so we will continue with the functions today. So last time we introduced functions, function and set notation, domain, range, the difference between relations and functions, and so on. And we did some graphs, tables, and so on. Today we're going to actually see how to graph functions. We're going to see what a function is first, then we'll see how to graph it. And each function has a different graph, could be a line, could be some curvy line, curvy graph, and so on. So start with the notation, or how does the function itself look like? Basically, the formula of the function. We call that the function notation. So basically, a function itself is a function is basically a formula that serves a purpose, serves a certain function, and it is basically an expression. It's an expression with variables and letters. First, for example, x plus 1, and then it could be a polynomial. It could be basically it's an algebraic expression, and we give it a name. That's an expression. Just give it a name. For example, f for function. F for function. We say the function f equals this, or we can call it other letters, f, g, k, whatever. It's just a name, just like the variables. So that's basically the actual expression. This is the name, and we put a variable in parentheses here. The same variable that the expression has. This just means f has the variable x. F of x, or f, the function, this has a variable x. If this was some other variable, for example, a, then we would put a here. Or we can replace x with anything as long as we do it on both sides. For example, we could put 3 here and 3 here, as we're going to see in a moment. So that's basically the notation of the function. And also, we say it's equal to y. So a function equals this, and this usually gives us a value of y. When we plug some value of x, for example, if you put 3 here, it would be 3 plus 1, or 4. So this will give us the value of y, or 4. We call that the evaluation. We're going to see that a little bit later. So for now, the most important thing is this is a name. This is the expression. And when we put a value here, like I said, we put some number here, we run it through the function, it gives us some value, the value of y. And that's basically what a function is made of. This changes. It could be first degree, could be second degree, could be anything, could be any sort of expression, or it could be even a polynomial. We call those polynomial functions. That's when you have maybe a binomial here, a trinomial, and so on. So function is basically an algebraic expression here. And we give it a name here of some letter. And then this variable here, it's a variable that it changes. So when we plug something here, we calculate this and it gives us some output, some value of y. And we call that basically the evaluation of functions. So basically a function is something you run a number through to get a value. Let me give you an example. So we say evaluating functions. Let's start with first degree. Basically a first degree. Think of this as a polynomial and the degree of it is 1. So we call this first degree or a linear. So linear, just like equations, linear or first degree, meaning the highest power is 1. And later we're going to see the quadratic. That's when the power is 2. Quadratic is basically for power 2. So evaluating functions, let's start with linear functions. So a linear function again, the power is 1. And you may have a number here, or maybe some number even before the x, but the important thing is that the variable has power 1. So let's see how to evaluate this function. So last time we worked with tables, we worked with set notation, graphs. So let's see how to make those actual tables. Let's see where they come from. So we make a little table here with 2 columns. One is for the x. The x again is the variable that changes here that we plug here. And when we plug x into the function, we evaluate this and it gives us some y value. That's where the table comes from. So we have 2 variables x and y, and every time you plug or you put a value x into the function, you get some value back. For example, we can put in maybe 2, 0, -3, just a few values, but you can put practically any other number you want to put. So maybe some positives, 0 and negative. So these are the x values, or this is what we call the domain. Remember last time we called this the domain. And this is, what did we call the other column, everybody? This is the domain. What did we call it?
Range.
Exactly, the range. So this is where we get the actual values. Last time we made things up, we made up random tables, random graphs, but today we're going to see actually how to make them based on a certain formula, certain function, in this case, x plus 1. So to evaluate, basically, you just plug x into the function, and simplify. Okay, so we're going to plug, for example, the first value here, 2. So x changes. X is a variable, could be any of these values or more. So we're going to put 2 here and here and see what we get. So it's going to be x, f, instead of x, the value now is 2. So if this changes, this also changes. So 2 here and 2 plus 1, 2 plus 1 is 3. So this is what we call the y value, the value that we get when we plug the function. So we put 3 here. So we just evaluated, okay? We just evaluated the function with this value. Then we're going to do these other value too, so other 2 values. And the way we read this, when you see f and x like this, we actually read it as, we say f of x. So this notation is f of x, which means the function f has the variable x in it like this. And that variable changes, like we'll see here. So we say f of x. When you plug a certain number here, we say f of 2, or basically the value of 2. The value of 2 is 3. When you plug 2 into the function, you get 3. So we say f of 2. F of 2 is 3. Okay, that's how you read that notation. Very simple again. It just means we plug the value 2 into the function, we run it through it, and we get some value. Same way we can evaluate this, the 0. So again, just replace the x with a 0.
0 plus 1.
That's right. So the value would be
3.
1. So f of 0 is 1. So when you plug 0 into the function, it returns a value. So that's the thing about the function. You plug something in it, and depending on the expression, depending on what you have here, it returns some value back. So it serves a certain purpose. This function specifically, all it does is add 1 to whatever number we plug in. If you plug 5, it will get 6. If you plug 7, it will get 8. All this function does is add 1 to whatever you plug in it. Some functions could be more complex than this, but this one, it just increases whatever you plug in it. It increments it by 1. So f of 0 is 1. Let's evaluate the third x value.
-3.
That's right, -3. So if you plug -3 here, what do we get? You plug -3 into the x, it would be
-3 plus 1.
That's right, which is
-2.
-2. So remember the last time the tables and we said whether it's a function or not. So with functions, every time each x value has a unique y value. Each x value, if you plug 2, every time you're going to get 3. If you plug 2, you will get 3 every time. There could be a number that's repeated here, but you cannot find a repeated number here. Hence why we called it a function last time. So there shouldn't be no duplication here in the values of x, but it's possible to have a duplicated value here. So each value, each x has exactly one value from here. Each element from the left has exactly one element from the right. So that's where the table, or the tables we saw last time, that's where they come from a certain function, like this one. So to evaluate, you simply plug something in the function and run it through it, and then you get your table. Once you have your table, we can turn it into, for example, relation or set notation. So set notation is, how do we write the set notation again? How do we turn this table into set notation? So we're going to give it a name.
F of x.
The set notation. So I'm going to give it a name, for example, table 1. And then we need colon, and then curly braces, and we're going to list all the ordered pairs. All the ordered pairs from this table, we're going to put them inside here. So what are the ordered pairs from this table into set notation? What are the pairs? The ordered pairs, everybody? We have 2, 3.
0, 1.
Comma.
Negative
Right?
2.
2, 1. Negative 3. Negative 2.
Negative 2.
Right? These are the order pairs. So we took a table first. The table came from here. Function again is x plus 1. So we plugged x's into the function. We got some values y. And again, that's the domain and that's a range. Once you have a table, you can turn it into a pair. You can also turn it into a graph. So each pair from here, each pair basically represents a dot on the graph. This is a dot, this is another dot, and so on. So let's put these in a graph. Let's plot these points and see how the graph looks like. That's where the graphs come from, by the way. The graphs we made up randomly last time. They basically come from the fact that we plug this into a graph. So graphing. So for that, we're going to need a graph. For the first time, let's see how to make a graph. It's easy, but in the future, we can just copy a graph from the internet and use it. The graph is made of 2 lines. Let's see if we can find some tools here. So you're going to need just 2 lines like these. We have the vertical line, or the vertical axis. And you also have a horizontal axis here. Okay, so as we said last time, we have 2 axes here. This is the x-axis, towards horizontal, and then the y-axis. Basically, we are referring to the same values here, the same columns. So this column is basically for all the x values, and the other column is for the y values. So again, this is the domain, this is the range, this is where to put the domain and range. And each pair here, or each value from here is related to one value from the other side. Together, they form an ordered pair. Ordered pairs In other words, each pair from here is a dot, is a point on the graph. And each one basically has an x value and a y value, x and y, so 2 and 3. And we can graph all these points in the graph. So the graph is made up of two lines, the x-axis, the y-axis. We have 0 in the middle, and the values of x here are positive, 1, 2, 3. The other side, the values are negative. And the values up on the y-axis are positive, also 1. We should say 1, 2, and 3. And the values down here are negative. The values below the 0 here on the y are negative. This is how you can make your own graph quickly if you don't have graphing paper. That's very simple again. Positives, positives, and here also positives and positives. So the y value, the y-axis is vertical. This one is horizontal. So that's an empty graph. And inside of here, we can put these points. We can plot. We say we plot these into the graph. So 2 and 3, so x2, y3. First, you find the value of x on the x-axis. In this case, it's 2, so we're going to find 2 here. From there, based on the value of y, if it's positive, we go up. If it's negative, we go down from the x. If it's 0, you stay right here. So first you find this on x, then you either go up or down or stay on this point, depending on the sign of this. So how do we plot this point? So we start from 2, and where do we go from here?
Go up 3.
That's right, we have 1, 2, 3, because the y is positive. So this is basically the intersection here of the 2 and the 3, the x value 2 and 3. So they form together, they make a point. Make a point of intersection. That's a pair. In other words, that's a point from the graph of this function. Once we graph all of them, we're going to see what the shape of the graph looks like. The graph could look like this, could look like that, it could look like this. There's many and different shapes of the graphs. This is what determines the shape of the graph. The power of the variables, or the degree of this polynomial or expression. In this case, it's 1. It's a specific type of graph. We're going to see it in a moment. Then we want to graph 0, 1, x0, y1. So the 0 is always in the middle. And then from there we go.
Go up 1.
That's right. Go up 1 on the axis. From
0,
0 go
x.
vertically. That's right. We go vertically up. That's our second point. Then we have -3. X is -3. Y is -2. First, again, find this on the x. This is the x. Find this in the x and then go to the y. So the x is -3. The y is -2. So where do we go from this point?
Down.
We're going to go down. That's right. So the y is negative. So start from the x, which is on this axis. And then we'll either go up or down because the y is vertical. So in this case, we're going down twice. 1, 2. So all of those are the 3 points because we only chose 3. You can choose more, you can choose as many as you need to. And you will find more pairs. How does the graph look like? How does the graph of this function look like to you? Everybody, what do you think the graph looks like? What type or what shape is the graph?
A line.
Line.
Looks like a line. That's right. It is a line. And we use a ruler. We just join all these points together like so. So this specific function has this graph, a specific graph or specific line as a graph. And based on this table, and these values are actual values that we came up with from the function. So the function itself, the table, the subnotation or the pairs, and we put them into a graph. That's the reason why we call them linear. We call them linear because the graph is a straight line. And the power has to be 1. Okay, the power is 1. That's why they call linear or first degree, as we mentioned earlier. So if the function is first degree, the graph will be a straight line. And to find out exactly how the graph goes, you need a table because it could be going anywhere. Okay, there's many different ways the line could go, but to draw the line specifically, you need to make a table with a few points, at least 2 points, because if you have 2 points, that's basically should be enough to draw a line, but 2 to 3 points are enough when you draw a linear function. Okay, so that's basically how you draw a linear function. It's very simple again. Next time you see power 1, so expect the graph to be linear. Your points should not end up like this. One of them is wrong, or maybe all of them. You should all be linear like this. So for all the other linear functions, even if you have a number here, 3x and -5 or whatever, because of the power, it should be a straight line. Now let's talk a little bit about, so you can also tell it from the graph here. So this is the x, f of 2 is 3, right? What is f of 1 based on this graph? If x is 1, what is f of 1?
2.
It would be 2. That's right. This is the x and this is the y. It's not here on the table, but we can read from the graph if 1 is 2. What about, we did that one. So we can read pretty much any other values from here. For example, f of -1. F of -1 is?
0.
That's right. F of -1 is, if you drop it over here, is 0. Or you can see it also from here. F of -1, if you plug -1 here, +1 would be 0. So you can also read it from here. So the x, again, this is the x values, and we extend it where it meets the graph, then that's the y, and you drop that on the y-axis, that's the y value. So f of -1 is 0, and so on. You can find any other values. F of, what is f of -1? I mean, we did f of -1. What is f of -2? X -2, what is the y?
-1.
Exactly. So x is here. So you drop it on the graph, and you see it meets here. If you drop this over the y-axis, it's -1. So you can do f of the values, f of something from the graph. You can also do it in the formula.
Can you
So-
do more because I didn't get that, the F.
Which one?
Can you do more example of the F because I didn't get it, please?
Which f exactly?
So how I know which points we are units? I don't know.
You mean these ones?
Yes, please.
Okay, so so each value from here, x has, when you extend it or you drop it over the function itself, for example, x2, these are the values of x, so x and the y's. You can do it from here with the formula, or you can say f meets the graph here. Then if you drop it over the y, you'll get the y value. So 2 and 3 is a pair. And if you look at -1, I mean 1, f of 1 is 2. F of 1 is 2. So the x value is 1, the y value is 2. But it has to be vertical here. Once you meet the graph, you drop it horizontally on the y-axis to get the y. So we have 1 and 2. Okay, so f of 1 is 2. And also here we said f of -3, the x. If it meets the graph here, the y is -2, the y. So x -2, -3, y -2. Just like we did here. So f of -3 is -2, and so on. So we can read for any point from the graph, whatever it is, for example, this point. So what's the x and the y here?
-1.
So x is, start with the x first. The x is -2, and the y is, if you drop it over here, would be
-1.
-1. That's right. That's basically just the point, the coordinates of the points of intersection. And we cannot, again, we can either do them from here, plug something into the function, or if you don't have the function and you don't have the table, we can actually read the values from here. So any graph like this, and if you have a point, so the x is here, the y is here, you just read the value, whatever it is. For example, x1 here, and the y is 2. So we can get the coordinates. We can either put pairs on a graph, or you can read the coordinates from the graph from a line or a point. So this is a linear function. Again, when you see a linear or first degree, expect your graph to be straight. It should not be anything else. If the power changes here, the shape of the graph, the type of the function change also. Now let's talk a little bit more about the domain and range. So the domain again is the x values, the y is the range. But we only took 3 values here. This doesn't mean that's all there is to it. There's actually infinitely many points. The line does not stop. The line actually extends in both directions infinitely. So we have infinitely many pairs here. We only chose 3. That doesn't mean we only have 3 values here for this function and 3 values of the y. We actually have infinitely many. We can't list them all. We can't list all the values here. So instead, so the domain, basically you can plug any value here. You can plug any number you can think of, like a 5, 0.1, 3 billion, whatever number you plug here, you'll get some number on the other side. So you can plug any of the real numbers. So the domain is all the real numbers. Meaning you can plug any number you get. The domain is basically x, could be any number. And since the line, again, since we can plug any x we want, at the same time, each x will have a y value. So the y also will have infinitely many values. So the range or the values of y is also all the real numbers. So the x basically is all the possible values. So there is no limit here. It's not only these 3, any real numbers. And so this notation here doesn't work when you have many values. It usually works if you have limited numbers of elements, as we did last time. For example, if you have a table with exactly 3 rows, then you need 3 pairs. If you have 5, and so on, you can put them in that notation. But when you have an infinitely many numbers for domain, we prefer another notation called not set notation, but interval. We call it interval notation. What it means is, since we can't list all of them, we have literally infinitely many values. We can't list all of them. We can say the domain is all real numbers. That's one way to say it in a sentence. And that said, you can't list all of them. Or in the interval notation, we just basically say the domain
from minus infinite
okay to
positive infinite.
That's right. So that's another way of saying this sentence. So domain, that's the name, colon, and instead of using curly braces, as we did last time, use these when you have limited values, like 4 or 5 or whatever, some specific number of values. But if it's unlimited, basically just use interval notation. So set notation, we use curly braces. Interval notation, we use parentheses or brackets. We're going to see when we use brackets. So this basically means all the real numbers, because we can represent them with a straight line. We have 0 in the middle, the numbers go up and up, all the way to positive infinity, and here the numbers go down. So this means all real numbers. So this or this or this mean the same thing. You can say it in a sentence, but a lot of times the question will say, write it in interval notation, not set notation, interval. So for interval, we just need 2 values, the lowest and the highest. the lowest possible and the highest possible. And we basically get this. But if we have like few values, specific values in a table, we can use subnotation and we list all those pairs here. Here we can't list all the pairs. We chose 3, but there's actually many, many others. Infinitely many, because the line extends in both directions. Keeps going up to positive infinity here, and it goes to negative infinity in the other direction. So the domain is unlimited. The range is also all the real numbers. So we're going to represent it with, again, we need a name, we need a colon, just like here. But the difference is, instead of using curly braces for interval notation, we don't need all the elements. We only need the lowest and the highest. And we close the parentheses. That's all. That's basically all you need when you do the domain and range for linear functions. So from now on, whenever again you see first degree function, it's a linear function. Now that the line will be, or the graph would be a line, straight line. And also now that the domain and range both would be unlimited, both would be any real number. Some functions have restrictions, but for linear functions, it's basically unlimited. The domain and range, you could do any value here, any value you can think of. You plug it in, there's gotta be a unique value for that x on this side. And let me give you another example of the interval notation. Sometimes it's limited. Here it's unlimited because it's a line, it extends in both directions. But let me give you another example of, we give you a graph like this. And then a graph is always made of x and y. Graph could go from here, for example, to here. It doesn't have to be unlimited. So if you see arrows on the sides of the graph, that means the graph doesn't stop. For example, the line extends in both directions. It goes to infinity here, it goes to negative infinity here. That's why we have the domain and range. But if you have a graph that looks like this, this means the graph stops here and stops here. That's it. The whole graph is here. It does not go beyond this. This is 1, 2. We have -1, -2, -3. For the y, we have maybe 1 here, -1. And we have about 2 here. We have 2 here. So this one, unlike this one is limited. So the domain, or the x values, they go between what values? The domain. The domain of this graph, or the x values. We only need the lowest and the highest. That's what the interval is. We don't need all the elements. We just need the lowest and the highest. So what is the domain of this graph? The other words, the x goes between what and what?
X2, X2, and
Okay.
Y2.
-3.
The x, only talking about the x itself, goes from 2 to,
-3.
Oh yeah.
that's
negative
right. So
3.
that's right. So that's the domain. So the domain again is only the values of x. If you drop this,
But is
one
the
value-
-3 included? I think no.
that's what we're going to talk about. These symbols here, they have
Yeah.
a meaning. That's right. We're going to see whether they're included or
I
not.
mean, it's colored, this is included, right?
That's right. Yeah. So the x values, they're all included between this and this. Again, with interval notation, we don't have to list all the elements like we do with set notation, because we have too many numbers to list. Don't think only about the integers, -3, -2, -1, 0. We have actually the decimals, we have the irrational numbers, we have 0.0001, 0.0002. We have many, many numbers here. Even though the interval may look small, it actually has all sorts of numbers. So we can't list all of them. Instead, we only list the interval. We say they go from here to here. So for example, population of a city. So we have a lot of people. And instead of listing, for example, the age of each person, you just say, oh, the population ranges from this age to this age, the lowest to the highest. You don't have to list all the ages and the ages of each person. You just say between this and this. Same thing here. We don't want to list all of them. So we say they go from -3 to 2. So the interval is for x goes from -3 and 2. But since it doesn't have these arrows around it, so we can't use parentheses, and at least from one of the slides. So if you look at the ends of them, the ends of the graph, again, if you see this, you see arrows, it means it goes infinitely. But if you see a circle or a point, so first the circle means this point itself is not part of the domain. The point itself, this value itself, -3, is not part of the domain. So we use parentheses for that. And this one, since it has a shaded circle or a shaded point, this means that number 2 is part of the domain. And we use bracket to mean the same thing. So if we don't have this, we can tell from here that -3 can be used, what is included, but 2 cannot be used, but 2 can be used. So let me just write that over here. So this, when you see a circle like this, that means the point or the value is not included. And if you see a shaded circle like this, that means the point of itself or the value itself is included, and we use brackets. Okay, so let me say that again. So this value here, whatever values, are between -3 and 2, all of them are included, meaning we can use them. We can use them, we can plug them, for example, in a table. We can do whatever we want with them. But since we have a circle here, this means skip this number. Don't use -3 because of this circle has a hole in the graph, so skip it. So any number higher than that will be fine. And for
How
this
can
one,
I understand, is it included or not included, just about the circle?
which one?
How I understand it's included number or not included? We have to
Because of
see the
this
circle.
symbol here. So this is what tells us.
Okay,
If
so
this is not included and the shaded one is included. So when we look at this graph, it means we can use any numbers between these, not including this one. Including 2, that's fine. 2 is included, that's why we used brackets. So even if we didn't have this graph, we can tell from here that this is included because of the bracket, and the -3 is not included. For example, if I said, give me let me give you some values. Is -1 in this interval? Is -1 can be
Yeah.
used, right? What about 1?
Yeah.
You can use 1 because it's here, it's within the interval. What about 5? Is it included?
No.
5 is beyond, is outside the interval. 5 is somewhere over here, so it's not in between. What about, let's say, -2?
No,
Why not? -2? Is it within the interval?
no, it's not on the line.
It is. -2.
Oh, you're
is here.
saying X. I thought you were saying Y. Yeah,
No, just -2. So
Yes.
those are fine. We can use. What about 0? X is 0. Is it an interval?
Yes.
Can we use it? Yes, 0 is here. What about 2 itself?
yes,
Is it part of the interval? Yes. What about -3?
yes.
No.
No. Again, it's
Oh,
not
no, no,
included
no, no,
because
no, no,
because of
no.
this circle. So every number between -3 and 2 is fine, excluding this. We're not including this because of this. If you see a hole in the graph, this means don't use that point. It's not part of the domain, but any other value from here to 2, including 2. So 2 is included, -3 is not included. So that's how you can tell the domain from the graph in interval notation. Again, interval notation, it means We only need the lowest and the highest, so you don't need to list all of them. We list all of them when we do set notation as we did last time. Same way, so the domain goes from -3 to 2. What about the range? The range of the values of y. It goes from where to where? For this graph, for this specific graph, this is the y-axis. So we need the range of the y values of this graph. What is the lowest value? And
-1.
-1.
that's right. So the lowest possible value could be included or not. We're going to talk about that in a moment. So it goes from -1. What is the highest possible value of y?
2.
The 2. So the lowest one is here, and the highest one is here, because the graph stops here and stops here. So basically, all the y values are here, between -1 and 2. There's nothing beyond that because the graph doesn't extend. Between -1, it goes to 2, the y values. Now, what do we use around -2, -1, and -2? Do we use parentheses or brackets?
Parentheses over -1.
That's right. So -3, since the x doesn't exist, is not included. The y also will not be included. So in order to have a y value, you got to have an x, because x, you plug it into the function, you get y. So if this doesn't exist, that will not exist also. So -1 is also not included. Okay, not included because you have a circle, you use parentheses. What about the other one, the 2? Use a bracket or parentheses here?
Bracket.
Bracket, that's right, because x is included. There's no problem with the x. Therefore, when you plug it, or when we miss the graph, there is a y here, so it is included, so it has a bracket. So that's basically.
I don't get it. Why is it so? Range, can you
uh,
find the range again? Why is brackets looks like this?
Because again, so the x, the interval, the x is this. For the y, it goes between -1 and -2, not including the -1, because if the x doesn't exist, the x does not exist here because it's not included. The y also is not included for that specific x. That's why we used parentheses here, not included. Again, parentheses means that they mean not included, and there is a circle like this. But for this one, so this one is not included. This one is fine.
Yeah.
So this value here is fine because
Not included, it's a regular basis. Okay, see, thank you. Got it.
all right. So in other words, for the interval notation, so we use the lowest and the highest value. We just look at the graph. If it doesn't stop, if we have this, these arrows, that means it goes to infinity. But if the graph stops here, that's all there is to the graph. And just remember, circle means not included, and we use parentheses. Shaded circle means that point is included in the graph, including the domain and range, and we use a bracket. So brackets mean included, parentheses mean not included. For infinities, for both of them, we always use parentheses. Just remember that. Not because they're not included, but we don't know what the value of infinity itself is. It's just a notation because there's no actual value for infinity. It's just a symbol, an imaginary value. So always use parentheses around infinities and brackets for included, parentheses for not included.
Questions like this was in homework 7, so it's better to do it after this class because I didn't know about infinity.
Yeah. So we haven't finished homework 7 yet. We did one part of it. This is the second part. So there will be some questions added about this in there. Okay, everybody. So now the main takeaway from here is, again, linear functions have power 1 and they are a straight line. And remember, for linear functions, the domain and range will always be this. It's always going to be negative infinity to positive infinity, which means you can plug any number you want here. And every time you do, you can get some real number. Interval notation works by listing only the lowest and the highest values of a graph, as seen on the graph, or as seen from your graph or function. And remember when to use brackets and parentheses and yeah, parentheses. So that's linear function. Okay, again, the takeaway here, remember linear. The power is 1. The graph will be straight line, and this always going to be true for linear functions. Next time I give you a function like this, and I say what is the domain of this function? You look at it, you say it's linear, the line extends in both directions, therefore the domain is all real numbers. And in interval notation, you would say it goes from negative infinity to positive infinity. Pretty quick and pretty simple. Each function has its own power, which basically changes the graph, changes the values, changes a lot of things, changes the domain and range also, as we're going to see. So before we look at another function, another degree, another type, and do the same thing again. Any questions, everybody, about this part? Any questions about the graphing, the table, the interval notation? Please let me know if you have any questions before we move on, everybody.
No questions.
I have lots of questions, but I'm pretty sure I need tutoring at this point. So, yeah.
This is your first time here, Tamara?
No, I'm not that well with math. I don't like algebra, I'm not gonna lie. So I'm definitely gonna need tutoring.
You've never, this is the first time I see you, right? In this class?
No, not the first time you're seeing me. I didn't come to class last week.
All right, we'll talk about it later, okay? Email me and we'll talk about it. All right, and let's move on to another function. So now let's do another, like I said, another degree, another type would be second degree. So linear function, we call them second degree, or we can call them quadratic. So linear function, that's when you have, so linear function, that's when you have power 1. Quadratic function, that's when you have power 2, quadratic. And this power will change the graph, will change the table and everything. So let's see how to graph one of those. Quadratic. Okay, so again, or we can also call them second degree. Second degree, again, because of the power of the variable, so second degree. An example, maybe f of x equals, for example, x to the second minus 1. So you look at it, this is a binomial, and the degree of it is 2. So just like with the degree of polynomials, this is the degree of this function. So the degree is basically 2. And this will change like I said, the table, the graph will change. So let's assume we don't know how the graph looks like yet. So we don't know how it looks like. So we're going to need a table. We're going to need a few values, a table like this. Then we're going to take that table and put it into, turn that table into a graph, basically the pairs or points. Each one of these is a point. Let's do the same thing pretty much. We're going to repeat the same thing with this function. So the higher the degree is, the more points you need to take here. So x and y. For a linear function, I would say take 2 or 3 values. That are enough. 2 or 3 numbers here are enough. And the higher the degree, the more points, because the graph looks more curved, and the shape changes as the power changes. So the higher the power is, I suggest you take more points, as many as you can. For this one, let's take at least 5. I'm going to take maybe 1, 2, take 0, to basically a couple of positive numbers, 0, -1, and -2. Okay, so at least these 5 values, because again, it's second degree, the graph is going to be different. It's not going to be a linear graph. I know that for a fact. All right, so we have the function. Basically, we have an empty table which we can fill. Gonna fill it out with some values. By the way, you can make up your own table like this, or the question may give you certain values to use. If it gives you certain values, use those to find the y. Or if it doesn't give you, feel free to use some values like these small ones. Okay, usually, I would go with these values: 2 positive values, small ones, the 0 itself, and 2 positive and 2 negative values at least. Okay, so we have the function, we have an empty table. How do we find the values again of y here?
We plug the x
Plug the x where?
on the function. For example, f of 1 is 1 in power of 2 minus 1.
That's right. So to find, so each value of x should have a value of y. So to find this value, we're going to plug it here. We're going to plug the x here. So it's going to be f of, so instead of x, we're going to put the first value, 1. So we're going to put it here, replace that with 1. And this will be minus 1, and this will be 0, right? So f of 1 is 0. So we have our first pair, but our first dot on the graph, we have it. We're gonna, once we finish the table, we'll put all of them in the same graph. Then we have 2. We're gonna plug 2. What is f of 2? If you just look at it here, what do you get if you plug 2 there?
I believe 3.
3, that's right. So it's gonna be 2. So you're gonna put 2 here and also replace this by 2. So it'll be 2 to the second minus 1, which is 3. So we're gonna put 3. So f of 2 is 3. F of 1 is 0, and so on. F of 0 is
F
we
of
plug 0 here.
0 is minus 1.
Negative
That's
one.
Negative 1.
That's right, be negative 1. Now f of negative 1 will be, again, we're going to plug the negative 1 here and here.
Yeah,
Negative
0,
1. Okay, negative 1.
0.
That's right. Negative 1 to the second is actually 1. Negative 1 times negative 1 is 1. Minus 1 is 0. Finally, f of negative 2. Again, plug negative 2 here, plug negative 2 into the function.
3.
That's right. We'll get 3. Negative 2 to the second minus 1. So negative 2 to the second is negative 2 times negative 2, which is 4. Minus 1 is 3. So should be good enough for now. See, we took at least 5 values because the degree went up. For degree 1, you can use 2, 3 values, but the higher the degree, again, the more points you need to take. So we'll put all of this, we're going to put all of these values in a graph like this one, and see how the graph looks like. Again, you can make up your okay, so you can make up your own graph like this, or you can use a graphing paper, you can print it out. Let me grab one. Just going to grab one from the internet quickly here. It's easier that way. It's more clear when we use graphing paper. Just type graphing paper or empty graph or something, and we'll give you a bunch of options. Okay, so which one looks good? That looks pretty good. All right, this is five. You make sure the graph you choose has all the numbers. As a clear graph has all the numbers and so on. Let's see if we got this one. All right, so this one should be pretty good. And let me see if we can drag it here. There we go. I'm just going to copy this and basically paste it every time from now on. Okay, so this is our graph. And all we have to do now is take these points. So each one of these is a point. For example, point A, B, C, D, and A, and E. So each pair, again, has X and Y. So this is the X-axis. Again, as you can see, the Y-axis. So we need to put all those points on this graph. How do we plot again 1, 0? Where do we start? Where do we go? For 1, 0. Where do I find it here?
XY, X1. Put
Okay.
X1, 0. So it's on the X line.
That's right. So first we start from X, then you go to the Y. X is 1, which is here. In the Y, either go up if it's positive, go down if it's negative, or you stay right here if it's 0. In this case, it's 0,
on
so
the
we stay,
line.
that's right, we stay on the X-axis here, on that point. So that's our first point. Then 2, 3. So we're going to start from X2, and then go up to the Y, because the Y is positive. So 2, and go up. 1, 2, 3. What about this one? 0, -1.
Stay on X. No,
Let's
wait, you're
start from
asking
X.
about C, right? Yes.
Mhm.
Go to the X, stay on 0, and then go down 1.
Exactly. So we're going to start from
On the
this,
Y.
start from X0. So 0 is always in the middle. So we're going to start from 0, which is here in the middle. We're going to go down once because the Y is negative. We're going to go down this time. And then we have -1 and 0. The X is -1, which again should be always on this axis. The first one is always on the X-axis. So we start from -1. And what do we do from there? Start from -1. The Y is 0. So
Stay on,
X.
yeah.
stay, that's right, because the Y is 0. So we're not moving up, we're not moving down. We're staying right here on the X-axis. And finally, -2 and 3. X -2, Y 3.
Up.
Where do we start?
Go to -2 on the X-axis and go up
Okay.
3.
That's right. So the X is here and we're going up because it's positive. So we're going up 3. 1, 2, and 3. Do you see can you see the shape of the graph now?
Yeah.
This is starting to take form. What do you think the graph looks like?
It's not a function.
What
It
do
It's
you
a
see there?
function.
Is a parabolic one?
Parabolic. Okay.
It's
What is the what is the
like
shape of it?
curve, like
It's a curve.
Yes.
Half the
Like-
circle, something like
Like
that.
it's like a U-shaped graph, right?
Yeah.
Not a V-shaped graph.
No,
These are not straight. Okay, these are not straight lines. It's like a little curve like this.
Uh-huh.
So that's all the quadratic functions have that shape. So remember, from now on, when you graph a quadratic or a second degree function, so expect your graph to look like a U, either facing up, sometimes facing down. Depending here, if you have a minus, it would be facing down instead. It would be this way. Now it's facing up. Depends on the sign here. If it's positive, it's facing up. If it's negative, faces down. So now all you have to do is carefully try to join those points. Again, not with a ruler. It's not a line. This is a straight line. It's a linear equation function. Here, just carefully try to join those by hand. Doesn't have to be perfect, but just curvy enough. Again, avoid making it look like a V. It's going to be a little hard, especially with this pen here, but something like this. That's pretty good. And it does not stop here. Keeps going infinitely up. we chose a few values here, it doesn't mean these are all the only values we can use. Again, we can use any values here for the quadratic functions, just like linear functions. The domain is infinitely or unlimited. You can use infinitely many values. We choose easy ones, positive integers, negative integers, instead of using decimals or fractions or something else. But here, basically, it goes up to positive infinity. As you can see, the x here goes up. So the x here is 1, then it's 2, then it's 3. So this keeps going up. Basically, the x goes up. In this direction, the x goes to negative infinity. So it's -1 here, -2 here. And as it widens, okay, it doesn't go straight up or vertically. It kind of widens up as it goes. So it's more like headed that way and that way. It's not going to be close to this anymore. It's going to keep going like almost like that. Something like this. As you can see, it doesn't. It basically it converges or it widens up as it goes up. So this direction, it goes to negative infinity. This direction goes to positive infinity and negative infinity. So we have -1, we have -2, we have -3, and so on. So we have quadratic formulas graph. It has a name. We call this, as someone mentioned, call it a parabola. That specific graph with that shape, U shape, the actual name for it is called a parabola. Okay, again, it could be facing up or down. It doesn't matter. If you have a minus here, it will flip all the signs here, and this will be facing down. It will be like this, like I said, but it's always going to be this U-shaped graph. Okay, so we started with a function. We put in some values. We got some values here. Again, you can make up your own table, unless the question gives you a table to fill out. That's fine. If not, it's easy to make your own. Plug these values into the function. You get some values here. And each one of those is a point, basically. Each one of these is a point on a graph. Once you join those points together, you'll get the shape of the graph. In this case, it looks like a U-shaped graph or a parabola. So what is the domain again in interval notation of this function? What is the domain or x?
So notation 1,
-infinity to
2, 0,
So
negative.
these are the ones we choose, but we can choose any number. Okay, just because we chose those, there's a few of them, but generally it's all real numbers. So interval notation. So the domain.
-infinity to positive infinity.
That's right. So it could be any number. So you see how the graph goes in both directions here. So that's basically the domain or the x. You can choose any value here. These are a few values of the domain, but not all of them. But generally, we can use any value, and we get some value of y back. From the graph now, what is the range or the values of y? From where to where?
From -1 to +infinity.
That's right. So for the x, as you can see, this is the x-axis. The graph extends in both directions infinitely, but for the y, it starts from here. It starts from here and it goes up where? So it's 1 here, it's 2, 3, 4, 5, and so on. So it starts from -1 to where? Does it stop? Does the y stop if the graph
No.
doesn't stop?
On the x-axis infinity.
So we're towards what value? So it goes from -1, the smallest value, the minimum value, to positive infinity, as you can see, because if the x doesn't stop, the y will also not stop. So it's the y here is 2, 3, 4. As this goes up, again, this does not stop. So as the x goes to infinity here, and negative infinity here, the y goes up. But the minimum value here, which we call this the vertex. Okay, that minimum value of the parabola is called the vertex. So it starts from here and it goes to infinity. If the graph was facing down, If the graph was facing down, then it would be from -1 going down to -infinity. If the graph was facing down, so it would start from -1 going down to infinity. But in this case, it starts from here and it goes up from -1 and keeps going up to infinity. So here is a takeaway again from quadratic functions. Remember, the power is 2. And remember that the graph is a parabola. And the domain will always be this. The range will change, but the domain will always be this because the graph, whether it's facing up or down, is always going to be extending to both directions, positive infinity and negative infinity. The range, however, depends where the graph is, because the graph is not always going to be here. It could be here, for example, then in this case, about 6.5, starts from 6.5 and goes up. It could be maybe here, could be here, could be there. The x will always going to be extending in both directions, but the y, the starting of the y, depends on where the graph is. Could be located here or there. So here basically starts from 6 and goes up. Here starts from 8, from 0. The y here is 0 and goes down to negative infinity. So this will not change. The domain or the range will change depending on where the graph is. So that's the takeaway again from the quadratic functions. So quadratic means second degree, means parabola. The domain will always be this. So if I give you a function like this, and I said, what is the domain of this function? Or what's the domain in interval notation? No need to do all this work just to tell the domain. We can actually tell it from the power. So when you see the power 2, you know that the domain will be this. So you can write the domain is this immediately. Unless I say graph it and then read it from the graph, then you will need to do this. The range, again, will change. By the way, should we use a bracket here or a parenthesis around -1?
Think blanket.
Why?
Negative one, because it's fixed.
What should we use around -1 and why?
-1 is included, so we have to.
Exactly. So as we said earlier, unless you see a hole in the graph, there's no hole in the graph here. So there's no hole in the graph. This graph is continuous. Unless you see a hole in it, you would use parentheses. There's no hole in it, it's just one continuous graph. That means the -1, which the graph starts from for the y, is actually included, so it should be a bracket, not a parenthesis. Okay, so the domain again will always be the same for quadratic functions and linear functions. The range for these will change depending on where the graph is. Again, it could be anywhere on this. Like I said, this point is called the vertex, which is basically, it's this point here, 0, 0, -1. This means basically the lowest point of the graph, the lowest point or the highest if it's facing down. So that's what the vertex is. You can just read it. In this case, x is 0. What is it? The y is -1, x is 0. This point here. So that's the vertex. What else? I believe we covered the domain, the range, quadratic functions. This is basically a continuation of what we started last time. You know, those basic terms we spent last time talking about. Told you that we're going to expand more on them. So this is some of that. And to still have more to talk about when it comes to functions. There's a lot of information in functions, like you see. But the previous lecture is important for understanding this one. All the basic terms and the concepts we introduced last time, we're basically expanding on them in this today's lecture, and also in the next maybe at least two lectures, we'll still be talking about functions. Okay, everybody, any questions, especially here about the quadratic functions? Everyone, the interval notation.
Quick question, Professor.
Mhm.
We're not gonna have this on the quiz, right?
Not this, no. Only from 1 to 6. This is, I believe, homework 7, part of homework 7. So it's not going to be in the quiz. In a future quiz.
Okay.
Could you please repeat what is vertex, what is parabola?
Parabola is the name of the graph because it looks like this.
Mhm.
The vertex is just the lowest point. The lowest point.
Vertex, lowest point, okay.
Yeah. And this, the name of this graph is parabola because of the shape of it, the U shape. Could be up and down. This also would be the vertex. If it's facing down, this also would be the vertex. And again, it's also a parabola. So bottom line is now how to tell the degree just by looking at the function. Again, have some basic information. For example, you see this, now it's linear, now the graph is a straight line, and also know that the domain will always be both, domain and range both will be this for linear functions. Don't worry about all the details, just the main takeaways here. Of course, the domain is this, and if we have a graph, we can tell the domain from the graph. Could be an unlimited graph. If it's unlimited, then it means it goes from negative infinity to positive infinity. Or if it's limited, then you just read exactly where the x goes, the values of x from where to where, and also the values of y. Second degree function, or also call them quadratic functions. Remember that the degree is 2. The graph will be a parabola, and the domain will always be this. The range changes, but the domain will always be this. As it is, you can graph any function of any degree. If you don't know, for example, the shape of a graph or the domain or whatever, the range of a graph, you can graph any function the same way. Choose a few values here, put them on a graph, and you'll see the shape. It could be a line, could be a parabola. Sometimes it looks like this. Other times it looks like this. Sometimes it has 2 parts like that. So it all depends on basically the power and the expression here. Let me give you one more example maybe for the domain and range. If anybody has any questions, as always, after the class, after we take the attendance, if you have any questions, please stay. I'll answer all your questions after the class ends. So we can address any questions. Let me give you a couple more problems here before we go. Again, a lot of times it says write the domain and range in interval.
What did you say, madam?
Interval notation. So let me give you another graph here. All right, so we saw the graph earlier. You may see also a graph that looks like this. Something like this. And another graph, just random graph, and it will ask you the domain and range in interval notation. So look at this graph, tell me the values of x. The value of the values of x, they go from where to where? And also the range, the values of y. So for this graph. Just read them from the graph. So what is the domain in interval notation?
But the
Meaning
graph touches 0.
the x, so with the domain, we talk about the values of x, right? So the lowest x value looks like it's 0, right?
Yeah.
The lowest x value here. And then, so it goes from 0 to where? Does the x stop? So it's 2, 3, 4, 5, 10. Keeps going this way. Does it stop? Does not. So it goes to infinity, right? So the smallest, the lowest value of x on the x-axis you can get is this one, is 0. The graph was going all the way over here, for example. then it would be from -4 to infinity, but the lowest x value is here, go to infinity, always 0 around infinity. And is the 0 itself included?
Bracket.
So included here, right? The 0, we don't see a hole here, so it's included, we use brackets. That's the domain. What about the range? Meaning the values of y of this graph. What is the lowest and the highest values?
Is -2.
That's right. The lowest value of y for this graph is -2.
And it is not included.
That's right. It is not included. So we're going to use parentheses or brackets.
Parentheses.
Parentheses. And the y
Parentheses.
here, that's right. The y here is -2. And what happens to the y? What does it go afterwards?
Goes to infinity.
That's right. It keeps
Infinity.
going up. So as the graph goes up, as you can see, it's -2, this, 1, 2, 3, 6, 7, and so on. It goes up. So it goes to infinity. If the graph was facing down, then it would be going down to -infinity. But it's going up. So it starts from -2, which is not included because of this circle, and it goes up to infinity. So you can tell the domain and range from the graph without having a function, without having a table. You can do that easily. And if you have to graph a function, and you can tell a lot of functions, you can tell just by looking at it. So linear functions, the domain is always -infinity to +infinity. This also, it's always this. Again, no need to graph unless the question says graph it and then read the domain and range from the graph. So, yeah.
About domain in this function.
Mhm.
So 0. It's 0. So we have to see on this vertex point.
No, there's no vertex here. The vertex is associated with parabola. So this is not a parabola.
Okay, so I mean, the closest point, I don't know how to describe it.
Mhm.
The last point,
Over the
Right.
x?
yeah.
Over the x, right? Yeah, so that's the
Why is it
first
0?
x you can get, yeah. Because here, if you look at this point, if you drop it here, this point
Mhm.
touches the graph.
Mhm.
So the x here is 0.
So
If the graph was going, for example, like this, the x would be, it was going like that.
-3.
X, it would be -3, yeah. So basically the first x you can see and
Mhm.
also the highest possible.
Okay, got it. Thanks.
All right. Any questions, everybody, about this? Please let me know if you have any questions. So graphing the functions is not that hard. Just be careful with the domain and range and interval notation when you read them from the graph. And remember what we learned today about first and second degree. So remember this: domain, the shape of the graph, the name of the graph, and remember how to evaluate functions. To evaluate, simply plug numbers into the function and simplify. Also, you should know how to put the points on a graph, plot them, and based on that, you see the shape of the graph. We're going to talk more about functions, okay? As I told you before, there's a lot to talk about when it comes to functions. And the next, like I said, 2 or 3 classes, we're still going to be talking about it. But the previous lecture, again, was the first one, and it is essential. It is essential to understanding this. If you missed that class or still have issues with it, let me know, or review your notes. The lecture lecture should be on Blackboard, the recording. Okay, let me first take the attendance, and